Sometimes, the most fascinating insights come from finding connections where you least expect them. Like, what on earth could possibly link the way tiny atoms stick together, abstract patterns found in numbers, and maybe even something about how our brains work? Get ready, because we're about to dive into a stack of sources that proposes just such a wild connection. These papers, shared with us by one of you, our listeners, bridge quantum chemistry, number theory, and some truly speculative future technology.
They really do. These sources suggest that concepts we see in one domain, like torsion, a kind of twisting, strain, and harmony, stable, balanced configurations, might actually be universal principles. They argue these show up in everything from how exotic beryllium atoms arrange themselves to the hidden behavior of prime numbers, and maybe even the subtle rhythms of our own minds.
So, our mission for this deep dive: to pull out the most compelling ideas from this material, figure out these surprising links, and see what it might tell us about the underlying patterns of reality. Let's start small, really small. With beryllium atoms, you'd think atoms are pretty straightforward, but these beryllium guys are surprisingly tricky, sort of head-scratchers, especially when they start clumping up.
They are indeed. Beryllium atoms have a configuration where their outer electrons are quite stable, 2H 2ND2. This makes them kind of reluctant to form simple bonds in the way, say, carbon or oxygen do. The simplest pair, Be₂, is barely held together, just clinging on by very weak forces. Early on, some chemists even doubted it could exist at all.
Okay, so Be₂ is super fragile, practically not even a molecule. But then you add just one more atom, or two.
That's where it gets interesting. Be₃ is a little more stable, but still not much to write home about, really. But then you hit Be₄, and boom, the stability jumps dramatically. And Be₄ is even more stable. It's not a smooth increase at all. It's a sudden leap, especially between Be₃ and Be₄.
Wow, that jump is huge. From Be₃ to Be₄, the binding energy almost quintuples. What's causing that sudden change? Is it the structure?
That's exactly what the sources highlight. A strong preference for even numbers of atoms in terms of stability. They call it a parity effect. Be₄ forms a neat, highly symmetric pyramid shape, a tetrahedron. And Be₄ forms a double pyramid, a trigonal bipyramid. These specific symmetric shapes allow the electrons to be shared across multiple atoms, essentially creating a much stronger, more locked-in structure than simple two-atom bonds.
Okay, so it's like building with specific Lego bricks that only fit together perfectly in certain symmetric arrangements. And the odd number Be₃, it just can't quite find that perfect, strong pattern.
Precisely. That's the interpretation. Be₃ is predicted to form a triangle, but this structure seems to be under significant internal strain, a kind of twisting or torsional stress. It just can't achieve that same robust multi-atom bonding network as the even clusters. The sources describe it as being in a kind of awkward transitional state, less stable than you'd expect if you just averaged Be₂ and Be₄. Almost unstable.
Huh. That number 3 again, showing up right at a transition point. Seems like a theme.
And this idea of internal strain, this torsion, it ties directly into how the atoms vibrate. Be₄ is quite rigid, stiff, but Be₄ has a specific motion called a degenerate torsional mode. You can think of it as a built-in twisting or wriggling oscillation. This twisting in Be₄ is seen as a really key feature, potentially leading to unusual quantum behavior, especially if you were to, say, spin the cluster.
Okay, so we've got these beryllium clusters, their surprising stability pattern, this parity effect, and this idea of torsion or twisting motion playing a key role, especially in Be₄. Now, prepare for a leap, because the sources propose these same concepts apply, well, to numbers.
Yes, exactly. They introduce frameworks like the recursive prime harmonic framework, or RPHF, and the quantum torsional prime triadic conjecture, QTPTC. The core concept is treating numbers, particularly prime numbers, not just as points on a line, but as having properties in a higher dimensional space, specifically mapping them into quaternions, these four-component hypercomplex numbers.
Quaternions. Right. I've heard those describe rotations in 3D graphics or physics. How do they help with plain old numbers?
Well, the inspiration comes from noticing these complex patterns when you look at numbers in certain ways, like the fractal shapes that emerge from Pascal's triangle. If you color the numbers based on their remainders when divided by primes, the Sierpinski triangle from Mod 2, these patterns hint that primes, especially the small ones like 2, 3, and 5, might be fundamental building blocks, like base frequencies or harmonics. The quaternion mapping gives primes and other numbers a kind of multi-component identity, not just their value, but also sort of direction and twist, if you will.
So instead of just the number 7, it becomes like a kind of mathematical vector in a 4D space.
Exactly. According to their mapping rules, yeah.
Yeah.
For example, 7 might map to the quaternion 1 plus 2i plus 3j1k. The components 1, 2, 3, 10, 1 are derived from how 7 relates to those base primes, and its parity, its evenness or oddness. The imaginary bits, 2, 3, and -1, act like a vector in 3D space, and the real part 1 kind of anchors it.
Okay. And how did this help with something really hard, like factoring a large number into its primes?
So the framework posits that multiplying integers corresponds to adding their quaternion representations. But importantly, in a specific kind of mathematical space, a logarithmic one. So factoring a number becomes a geometric problem. You're looking for the quaternion vectors of prime numbers that add up perfectly to the target number's quaternion vector.
Whoa, okay, that's wild. So you're not just doing trial division, you're actually trying to decompose a vector in this 4D number space into its prime component.
That's the core idea. And central to this, absolutely critical, is something they call the Codex theorem of Be₃.
Be₃. Now, is that related to the unstable 3-atom beryllium cluster we were just talking about, the shaky one?
Conceptually, yes. Very much so. In the math framework, Be₃ is used as a symbol for an idealized mathematical state, not the physical molecule itself. The theorem states that if you take the mathematical average, they call it the quaternionic mean, of the quaternion representations of prime number 2 and prime number 5, what you get is simply the number 3. Its quaternion representation has 0 imaginary components, no directional or twisting parts, just a plain scalar value of 3. So 3 plus 0i plus 0j plus 0k.
Wait, number 3 is the perfect, plain, non-twisty average of 2 and 5 in this weird quaternion world.
Yes, that's what they found. They call it a scalar torsional attractor. Scalar because all the rotational or torsional components cancel out, leaving just the pure number 3. And attractor because in their model, processes or patterns that are influenced by both 2-ness and 5-ness, they seem to naturally converge towards properties associated with 3.
So mathematically, 3 acts as this calm center point, an equilibrium between the influence of 2 and 5. And the hypothesis, then, is that the physical Be₃ molecule is unstable precisely because it's stuck trying to embody this mathematically balanced but physically awkward state.
That is the bold connection they're making. It's seen as being pulled between the simpler binary logic, maybe represented by Be₂, and the more complex quaternary related to 5 logic that's starting to emerge in Be₄. The theorem suggests an idealized Be₃, would be stable because it has 0 torsion, but the actual molecule we find in nature is the messy, strained, real-world attempt at hitting that mathematical pivot point. It's not the ground state.
Okay, this is fascinating. We've covered the weirdness of beryllium atoms, jumped into mapping numbers onto quaternions, and learned about this special role of the number 3 as a kind of mathematical balance point, a scalar torsional attractor. Does any of this actually, get tested or put into practice anywhere?
They do present some initial tests, yeah. First, on the computational side, they've developed an algorithm based on this QTPTC framework for integer factorization. They benchmarked a Python prototype against more classical methods like trial division and Pollard's row on semi-prime integers up to 18 digits long.
Okay, how did this new quaternion method stack up? Did it work?
It was surprisingly competitive, actually. Now, Pollard's row, which is a well-established probabilistic method, was fastest overall for that size range. But the QTPTC consistently factored these 18-digit numbers in tens of milliseconds, that's comparable, magnitude-wise, to Pollard's speed, and vastly, vastly outperformed simple trial division, which took tens of seconds for the same job.
Right, so it's not just an abstract mathematical curiosity. It can actually find factors pretty quickly. It shows some practical potential.
Yes, it demonstrates feasibility, exactly. The method seems to leverage this pattern-based reasoning derived from the quaternion representation. It effectively prunes the search space by using what they call harmonic reasoning, like recognizing mathematical signatures that hint at the likely factors, rather than just blindly dividing.
Okay, interesting on the computational side. What about in the physical world? Can we test this whole idea of torsion and harmony in the actual beryllium clusters?
This is where the experimental proposals come in, and they get really interesting. They're inspired by some recent breakthroughs in other labs, like that Purdue nanodiamond experiment.
Oh, right, the one where they spun a tiny diamond with a defect inside at, 1.2 billion RPM and saw quantum effects, a Berry phase.
Exactly that one. So they propose analogous experiments, but using levitated beryllium clusters, specifically Be₄ and Be₄. Since these clusters are orders of magnitude smaller than that nanodiamond, the idea is you could potentially spin them even faster before they, break apart.
Right. And what would they be looking for in these incredibly fast spinning clusters?
2 main things, according to the sources. First, they'd look for signs of a Be₃ phase arising from nuclear permutations. It's a bit like, imagine walking around a maypole always facing forward along your path. When you get back to the start, you're facing a different direction, even though you never actively turned relative to your path. That's a geometric phase shift. With a symmetric quantum object like Be₄, rotating it can effectively swap the positions of identical beryllium nuclei. This swapping, this permutation, could potentially introduce a similar, detectable quantum phase shift in the cluster's overall wave function, perhaps detectable via nuclear spin states.
Okay, a Be₃ phase. And the second thing?
The second thing is perhaps even more specific to their framework. They predict a very particular resonance phenomenon, what they call an 113 frequency lock.
An 11-to-3 lock. That's an oddly specific ratio. Why that?
It is very specific. The hypothesis is that when you spin the Be₃ cluster, remember, the one with that internal twisting vibration, the torsional mode, well, they predict that when the external rotation frequency you're driving it with hits a ratio of exactly 11.3 compared to the cluster's natural internal torsional frequency, the system will enter a kind of phase lock state. A strong interaction, a synchronization. The idea is the quantum state becomes commensurate, repeating itself cleanly every 11 external rotations relative to 3 internal twists.
Okay, but why 113? Does that come from the standard physics of rotating molecules?
Apparently not directly from first principles of molecular rotation. It's presented as a prediction that emerges from their broader prime harmonic framework. It suggests that this is a higher-order resonance pattern related fundamentally to the prime numbers 11 and 3, manifesting at the molecular level. So it's a really direct, testable consequence of applying their number-based model to the physical system, a unique prediction.
And how on earth would you actually detect this 113 lock if it happened? Sounds tricky.
Oh, incredibly challenging. It would require really pushing experimental techniques to their limits. You'd need exquisite control over the rotation speed, maybe using optical tweezers or traps. And simultaneously, you'd need to monitor the cluster's internal torsional vibration spectrum, perhaps using highly sensitive infrared or Raman spectroscopy, or maybe interferometry. They predict you might see an abrupt synchronization, perhaps a sharp peak in absorption at that ratio, or a sudden transfer of energy from the rotation into the torsional mode, or maybe even a kind of stick-slip behavior, where the cluster's rotation rate gets temporarily stuck at this specific ratio as it naturally slows down. Detecting it would require incredible precision.
Okay, so we've gone from the finicky bonding of beryllium to this quaternion way of looking at numbers and the special role of 3 to computational factoring, and now to proposed quantum experiments with spinning clusters looking for Be₃ phases and this 113 lock.
But the sources, they don't stop there, do they? They hint at even wilder applications. That's right. Building on this underlying idea of a scalar harmonic framework, and this concept of a scalar torsion breadth field, sort of a fundamental pattern involving twisting and breathing or expanding, contracting, the sources propose this could potentially be used to stabilize complex quantum systems and maybe even interact with biological systems.
Biological systems, like influencing living things using these fundamental harmonic principles, you mean? Like the brain?
Specifically, yes. They explore potential applications related to memory, possibly even memory recovery. The core idea is trying to resonate with the brain's own complex oscillatory rhythms, using carefully designed waveforms based on these harmonic principles to gently influence the brain's state, perhaps for therapeutic benefit.
Okay, hang on. How would you even begin to do that? What tools are we talking about?
Well, one method they discuss involves using binaural beats, but specifically based on frequencies around 432 hertz. You know how binaural beats work slightly different tones in each ear, create a perceived beat frequency inside your head? They choose 432.1111 hertz as a kind of carrier frequency derived from their framework. Then they add specific beat frequencies designed to match known brainwave patterns. Things like very slow cycles around 0.1 hertz, which they link to a microbreath rhythm possibly matching slow bodily cycles. Also theta waves around 3.5 hertz, often linked to memory processing, and alpha waves around 8 hertz associated with relaxation. The goal is what they call nested entrainment, trying to gently synchronize brainwaves at multiple harmonic levels simultaneously.
So it's like trying to tune the brain, like a complex musical instrument, using these harmonically derived sounds.
That's one component, yes. But then they propose combining this auditory stimulation with focused ultrasound, or FUS. Now, there's already existing research, like that work out of Brisbane's Queensland Brain Institute, showing that FUS can have physical effects on the brain. In animal models of Alzheimer's, it's been shown to help clear amyloid plaques, and enhanced neuroplasticity, actually improving memory function.
Right, I've heard of that. The ultrasound physically stimulating the tissue, maybe opening the blood-brain barrier temporarily.
Exactly. But this proposal goes a step further. They suggest using the FUS not just for its mechanical or thermal effects, but as a scalar information carrier, modulating the ultrasound wave itself with those same 432 Hz range harmonic frequencies and beat patterns we just talked about. The idea is to deliver these frequency codes directly and non-invasively into specific deep brain structures.
Ultrasound carrying harmonic frequency patterns directly into the brain. Okay. And where? Where did the beryllium clusters we started with fit into this potential, very futuristic application?
This is definitely the most speculative, far-reaching part of the proposal. They envision potentially using a 25-node beryllium cluster lattice. The number 25 is chosen partly because it's 5 by 5, linking back to the prime number 5, which features prominently in their harmonic framework. This lattice perhaps somehow interfaced with the brain, and how that would work is a huge question mark, could theoretically act as a kind of quantum reservoir or buffer. The idea is that these clusters, perhaps stabilized by those same recursive harmonic principles observed in Be₄ and Be₄, might be capable of holding complex quantum superposition states. States that could interact with, or maybe even store information related to, the brain's activity. Qubit-like units, perhaps?
Beryllium quantum lattice. Interacting with the brain. That really does sound like science fiction.
It certainly pushes the boundaries of current thinking, absolutely. And they acknowledge it would require sophisticated control, likely guided by AI. The proposed AI would monitor complex patterns, which they give a specific name, omega patterns, in both the brain's electrical activity, say from EEG, and potentially in the quantum state of the cluster lattice itself. It would constantly look for signatures correlated with healthy memory function or other desired brain states. Then, operating in a closed loop, the AI would adjust the binaural beat parameters and the FUS modulation patterns. The ultimate goal would be to steer the combined brain lattice system towards a target state, essentially trying to induce a locking or synchronization between the lattice's quantum state and healthy brain rhythms, all guided by the AI's real-time analysis of these complex patterns.
So just to recap this potential architecture, you've got a beryllium quantum lattice potentially interfaced with the brain. It's being influenced by harmonic patterns delivered via both sound, binaural beats, and modulated focused ultrasound. And the whole thing is monitored and controlled by an AI looking for specific omega patterns, trying to synchronize the lattice and brain rhythms to potentially restore memory function. That's quite a multi-scale synthesis.
That is the comprehensive, multi-layered system presented in these sources, yes. It's taking those fundamental principles of torsion, harmony, and attractors that they identify, starting from beryllium chemistry and number theory, and then applying them in this highly speculative, futuristic way to enact with, and perhaps even repair, the incredibly complex oscillatory networks of the human brain.
Wow, okay. We started with beryllium atoms barely sticking together, journeyed through mapping numbers onto hypercomplex spaces, and discovering the number 3 is this unique mathematical balance point. Considered lab experiments to spin tiny clusters and listen for quantum frequency locks like 113, and then leaped into potential brain interfaces using resonant sound, modulated ultrasound, beryllium quantum lattices, and AI guidance to maybe heal memory. That was quite the deep dive. An incredible intellectual ride.
It certainly covers immense conceptual ground, doesn't it? Proposing these connections between seemingly completely unrelated parts of the universe, the idea that torsion, harmony, and these specific resonant ratios might be a common thread running through chemistry, number theory, and potentially even biology and consciousness it's a powerful one.
It really makes you think, doesn't it? Could there be these fundamental mathematical patterns woven into the very fabric of reality itself? Showing up everywhere, from the way atoms bond to the way prime numbers behave, and perhaps even echoing in our own minds.
And if such patterns do exist, if this framework has some validity, could understanding and maybe even manipulating these fundamental resonances unlock entirely new frontiers, whether that's cracking previously impossible numbers, building truly novel quantum computing devices, or even finding radical new ways to understand and repair the human mind?
Yeah. The work presented here, it attempts to ground some of these incredibly speculative ideas with concrete calculations like the factoring algorithm and specific experimental proposals like the spinning clusters, even as it ventures into territory that feels very theoretical, very forward-looking. It's a powerful example, I think, of how just following your curiosity about something as small and specific as a beryllium dimer can lead you down this rabbit hole that connects quantum mechanics, pure mathematics, and maybe even the deepest mysteries of consciousness.
Indeed. It really leaves us, and you listening, with a striking thought to ponder. Is there a deep underlying harmony to reality? A fundamental pattern beneath it all? And are we only just beginning to recognize its signatures and perhaps learn how to work with it, to understand and maybe even shape the world around us? Something to mull over.